Every few decades, a technology arrives that reorganizes human life. Electricity forced society to rebuild industry and daily existence around the power grid. The internet caused a similar reorganization. But in those previous eras, humanity had decades to build new infrastructure and adjust to a single, isolated shift. We no longer have that luxury. Right now, 6 entirely distinct, world-altering technologies are moving out of labs and maturing at once. The danger lies in the speed of this transition. When the rules of labor, money, and survival shift faster than we can build the institutions to govern them, society enters extreme instability. We are facing a century's worth of structural change compressed into a window too small for traditional systems to react. Energy is the master resource, and nuclear fusion is the ultimate goal. While scaling this to the global grid remains a massive engineering challenge, a U.S. lab recently achieved a breakthrough, generating more energy from a reaction than was required to trigger it. This proof of concept points toward a future where energy scarcity is no longer a physical law. If we can successfully scale this, tasks like global desalination or massive carbon capture move from being too expensive to being routine. But physical energy is only half the equation. Classical computers are limited by their linear nature. They process possibilities one at a time, creating a bottleneck for complex simulations. Quantum computers remove this bottleneck entirely by exploring millions of possibilities simultaneously. This allows researchers to simulate molecular chemistry natively. Instead of years of trial and error, a custom antibiotic for a resistant superbug or a high-capacity battery material could be designed in weeks. However, this processing power also creates a silent security crisis. Intelligence agencies are currently harvesting encrypted data, government secrets, and private messages, storing it in vaults until they have the hardware to break it open. This means decades of archived data could be retroactively exposed. The moment this technology matures, nations may find historical secrets becoming readable instantly. By removing physical limits on energy and digital limits on computation, we gain the tools to redesign the physical world from the ground up. To see where that redesign starts, look at our cities. Much of our current infrastructure is built around the limitations of human labor and the need for parking. Humanoid robots are turning labor into something that can be manufactured. Imagine a robot that arrives in a box, unpacks itself, and starts working 24/7 dark shifts in a factory with the lights off because it doesn't need to see the way a human does. On a farm, one person managing 200 robots could lower food prices by removing the cost of human fatigue. In construction, robotic crews 3D printing houses could collapse the cost of shelter. Transportation is seeing a similar shift. Autonomous fleets have already completed millions of driverless rides, moving from an experiment to a part of public infrastructure. Because these fleets never need to park, cities can reclaim land equivalent to building a new city inside the existing one. Short flights could be replaced by sleeper cars that travel while you dream. As human physical limits are removed from the cost of goods, handmade and human-served will become premium labels, much like organic is today. We are applying this same programmable logic to our biology. CRISPR has cured sickle cell disease by rewriting genetic instructions within a patient's cells. We are scaling this to the environment too. Scientists are editing mosquitoes to eliminate malaria, de-extincting mammoths to restore Arctic grasslands, and slowing the permafrost melting. The final frontier is the mind. Brain-computer interfaces are moving beyond treating paralysis and toward a form of technological telepathy. Projects are underway to stream camera feeds directly into the visual cortex of the blind. In early trials, signals have been recorded and decoded to transmit complex muscle memory directly to machines. This creates deep legal questions. If thoughts can be backed up to a machine, courts will have to decide if your internal memories are private property or data that can be subpoenaed. None of these breakthroughs exist in isolation. They are part of a convergence where each technology acts as a multiplier for the others. In this loop, quantum computers design the CRISPR edits that are then planted and harvested by robot swarms. Fusion provides the limitless energy for this ecosystem, while brain-computer interfaces allow humans to command the entire process through thought alone. The speed of this change means the world of 2045 will look as incomprehensible to us as our smartphone-saturated present would to someone from 1985. This shift puts a massive premium on adaptability. As entire industries dissolve, the ability to pivot between new roles and master new tools becomes more valuable than any static degree or specialization. The question isn't whether these technologies will arrive. The question is whether you are positioning yourself to ride this wave of convergence, or if you are waiting to be swept away by it.